Today I'm going to talk about periodical problems. Okay, periodic problems means something that some pattern will changes periodically. Okay, some objects in the pattern change periodically. Then you try to find out or identify some object in the sequence based on the period. Okay. So, so we have to do some division and we have to do some division and problems. So if you figure out the remainder, okay. First of all, let me say, parents, if you log into the Zoom online class, mute your microphone. Okay, I don't know why it's always shows up immediately. So when you log in, just make sure before you log in, make sure the microphone is muted. Okay, thank you. Especially when you're late, after the class. Okay, after the class begins. All right. So let's take a look at the first problem. In this sequence of letters, okay, what is a 2000th letter? Okay, now with a simple observation. Okay. Okay, I have to say it again. Next time, please, if after the class begins, when you log in, mute your microphone immediately. Okay, don't log in with the microphone on. Okay, sometimes kids are crying, everything happens. Disturb the class. Okay, remember. Okay. Thank you. I think my setting is that when you log in, your microphone is automatically muted. So make sure, okay, especially when the class starts. All right, so let's take a look at this problem. And I know some students maybe already have the answers. I got different answers actually. Okay, so this is a periodic problem. So you have to find out the specific blocks which shows up periodically. Right? Then use that division to solve the problem. So when you look at it, okay, you see that A, B, A, and okay, can you see the pattern? Yeah, let me check. There is always 3 A's between 2 B's, right? There is always a, right? So this is a pattern, and BAA or whatever, right? BA is a pattern, BA is a pattern, right? So this is a probably this you have to. It's not you have to sometimes you have to delete ignore the first letter or first few letters, then you see the periodic. Okay, then you see it shows up periodically. So this is a BAA, this every time those 4 letters, right, shows up except the first one. Okay, if you just look at AB, AAA, ABAA, and well, this is one way now. Yeah, and you can also look at probably can also look at ABAA. Okay, ABAA and ABA. That's better way. There's a couple ways to do. We have some problems. You cannot find the period unless you delete the first letters. So, okay, so you have to locate. You have to find out these 4 letters which shows up periodically. Okay, so this is a block you have to identify, and then if you just focus on 3 A's, then you have to cover the first letter A. Then it's called BAAA. BAA, it's also one block which shows up periodically, and then the problem becomes a little bit more complicated. So that's another way to look at this sequence. If you circle ABAA, then you see this block shows up periodically, right? All right. So now, then all you have to do is to see how many blocks, right? Blocks of 4 letters in the sequence, right? And the 2000, right? 2000 divided by 4, and you get you get 500, right? So that means 2000 is a multiple of 4. Okay, so 2000 is multiple 4. Therefore, the last one, you have a complete blocks here for 500 blocks of 4 letters. Okay, so that's A B A A. Okay, this will be the 2000th letter. Okay, so the answer is A. Got it? So the idea is to find the block in the sequence. It shows up, it appears periodically. Okay, then if you are given the number 2000, you just divide by 2000 divided by this 4. If the block contains 4 letters, and maybe divisible, maybe not, right? If you have a remainder and you get a partial block at the end. Okay, so here we 2000 is divisible by 4, so you have a 500 complete blocks, and the last block contains the 2000th letter, and which is at the end of the block. Then you solve the problem. All right, now take a look at the second problem. In the following sequence of symbols, what is a 150th symbol? It's a very similar problem. Okay, first of all, you have to figure out the block which shows up periodically, and I think this is a block. Okay, all right, how many symbols in this block? 5 symbols. Okay, so then you decide, then you divide 150 divided by 5. Okay, so it's going to be, okay, so it's going to be 30. So 30 is a quotient. 30 is quotient. That means 150 divided by 5, and you get 30 blocks, complete blocks. So the last one will be this block, complete block. It's a complete block. So that will be 150th symbol. Okay, so the answer is, yeah, that's easy, right? The answer is this. All right, great. Yeah, you should work on this problem when you see the question. Okay, and if you have an answer my question. Now we have something come late. Okay, make sure, yeah, don't turn on the microphone. Okay, now let's take a look at another one. Okay, a little bit complicated. In the following sequence of letters, what is a 47th letter? You got an idea, right? First of all, you have to figure out the block which appears periodically. So look at this block, right? HHOOKKK, 5 Ks there, right? Right. So this is a will be block. Okay. And how many letters there? I have 9 letters. Right? 2H, 2O, 4, and plus 5K. So 9 letters. So that's 9 letters. So the block contains 9 letters. Okay. 47 letters in the whole sequence. So you have to divide by 9. Okay. So you have this is going to be, so the remainder is 2. So that means 47 letters has 5 blocks of 9 letters plus 2. So this is the last block. Okay, the last block is partial block. Okay, it only contains 2 letters, which is HH. So that would be 47th. Okay, letter, right? Because that's a remainder. Remainder is 2. Okay, and the 5th block Okay, this is actually the sixth block. Okay, contains only 2 letters, and clearly the answer is H. How do you get K? How do you get a K? Okay, let me repeat again. Okay, you have a, okay, right? Do you see that? That's a sequence of, this is a sequence of, letters. And you look at the block which shows up, appears periodically. That block contains 9 letters. So every time you write 9 letters for each block, and you have 5 blocks plus 2 more letters. Okay, got it? Yes. So in each block, it shows up H H O O K K K K K K, right? So this partial block, the second letter is H. That's why the answer is H. Okay. All right. Now let's take a look at the next one. Okay, it's no, it's different problems here. Okay, these different problems. I'm going to count how many A's, how many B's here. Okay. Look at this problem, right? It's also periodic sequence. Okay, find the block, 1 block, and you do the counting. 1 block. So 1 block contains 6 letters. Okay, contains 6 letters. Okay, A, A, O, O, B, 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 B. Okay. How do you figure out the number of A's? How do you figure out the number of letter A's, the number of letter B's? 1 block contains 2 letter A's, 3 letter B. So what you have to do? You have to find out the total number of blocks, right? Maybe there's another partial block should be also considered, right? The partial block. Okay, a complete block, how many complete blocks, how many partial blocks in the sequence of the first 150 letters. Okay. Any answers? Okay. All right. First of all, I have to repeat again. Don't type too many nonsense words there. Okay, Maxwell. I have to give you a warning. Okay, you just need to tell me total number of A's and total number of B's. Okay. Thank you, Edward. So we are getting answers. Okay. Great. All right, so let's figure out how many complete blocks and plus 1 partial block. Okay, so you have to divide 150 divided by 6, right? Then here and 2, right? And 5, right? So 150 is divisible by 6. So that means there are 25. There are 25 complete blocks, no partial blocks there, no partial block, right? So 25 blocks of letters, okay? So A, for letter A's, each block contains 2, so it's a 50. For letter B, each block contains 3, so it's 75. Good. If there's a partial block, and then you have to add a couple more, add 1 or 2. Okay, good job. So now do this slightly different, similar problem. Maybe you get a partial block here. Okay, take a look at in the following of 375 letters. Okay, so we don't know when it stops, right? How many are B's? Okay, first of all, you identify the block which appears periodically. Okay, and then which appears periodically. Then you count the number of blocks in the sequence. Okay, it's a finite sequence. You only have 307 letters. Stop somewhere. And there's also probably a partial. There's also partial. There's a partial block. So thank you, Michael. Michael gave an answer already. Okay. 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 So how do you? So let's count. Right. Let's figure out the block. Right. So A and 4B. I think this is a block. Shows up periodically. Okay. So you have to 375 have to divide by, this is a 6, right? Yeah, 6. Total 6 letters. Okay. So here you get, okay, so you get 62 complete blocks, right? And the 1 partial block. So the partial block contains 3 letters. So you can even write down AAB. Okay. So this is a partial block, right? At the end, right? So now you want to count how many B's, right? The number of the B's depends on how many blocks, right? 52 blocks times each block contains 4 letters, 4 B's, and then plus the last one, which partial block contains only 1 letter B. Okay, then you do the computation. So there you will get 249. 249. Good job. Good job. Maxwell, you cannot give me 2 answers. Okay. Your answer must be definite. You cannot say, oh, this or that. Otherwise, your answer is wrong, counted as a wrong answer. Okay. Okay, so now let's do the next one. In the following sequence of numbers, and which letter is 39? Okay, this is a new type of problem. So let me do it for you. All right. So this is, yeah, you look at this picture here, right? So A, B, C, D, the 4 letters. Then you write down the numbers from the left to the right. And again, when you change the row, also from left to the right. Okay. So actually, it's a periodical, when you write the letters. Okay. So you needed to know 39, how many blocks of 4 numbers, right? So it's going to be 39 divided by 4, okay? 39 divided by 4, let me write somewhere else here. Okay, 39 divided by 4, okay? So the quotient is 9, and the remainder is 3. What does that mean? That means 39 is 9 blocks of form plus 3. Okay, so that means you have a 9 rows, complete rows, and plus 1 partial row. Okay, so you have a 9. Yeah, so 9 complete rows, 1 partial row. Okay, so the 1 partial row contains 3 3 numbers. So that means 39, 38, 37. So this is a partial row. Okay, so 39, above 39 is C. So the answer is C. Okay, all right, just keep it going. Eventually get 37, 38, 39, and the 40, right? Yeah, 40 is not there, 39, and above 39 is C, above 40 is D. All right, good job. Okay. And let's do the similar problem. I'm going to ask you to do this problem. Okay, we're going to click back. It's easy. Right, in the following sequence, and which letters are the numbers? So 36, 43, 80, 78, 2000. Okay, we have 4 questions here actually. Okay, we do one by one. So let me write down the answer here. And which letters for the number 36, 43, 78, 2000. Okay. So let's express 36. Yeah. See, 36 divided by 4. We have 4 columns here. It's 9. So 36 is 9 times 4. You have 9 complete rows. That gives you D, right? Right? Yeah. Then because 36 will be the last number in this block. 43 divided by 4, right? The remainder is clearly 3, right? Right, the remainder is 3, so it's a 10 times 4 plus 3. So that would be you have a partial row at the end. The partial row contains 3 numbers, so that must be C, the third one, okay? And the 78 divided by 4. Right, the remainder is 2. So that means it's 19 times 4 plus 2. Okay, the last row contains 2 numbers. So that must be B. Okay, then 2000 is divided by 4, clearly. Okay, it's going to be 500, yeah, times 4 plus 0. Okay, that means it is D again, right? The last row is complete row. Okay, so DC, BD. Yeah, great. Oh, what is G13? Sorry, that was typos there. Right. So now we're going to look at this. This is slightly different. Okay, it's challenging much. I'm going to move up a little bit. Okay. Take a look at the 2001 students are arranged in the following way. In which column is the last student? Okay. This is a okay. This is a completely different problem. Not complete, but it's a little bit weird. Okay. First of all, it's still periodic problem. Okay. You need to find out the rows which shows up periodically. Okay. So you have to find out. The rows shows up periodically, right? Now take a look at this, right? This is first of all, the first row, okay? The first row never shows up in each row after the first row, only contains 4 numbers, right? You never got 5 numbers again. So that's exceptional. You probably have to exclude it. Okay, that's exceptional. Right after the first row, okay, you see the pattern. Right? 6, 7, 8 from right to the left, first of all, right? Right, that's the pattern. From left to the right, from right to the left, then from left to the right, and shifted by 1 row, right? So 6, 7, 8, 9, 10, 11, 12, 13. Then again, 14, 15, 16, 17, then 18, 19, 20, 21. Okay. Let me check. So this is I'm typing wrong. I shouldn't put this here. Okay. So this is the pattern. So when you solve this problem, forget the first rule. Okay. Forget first rule. If I put 22 on that corner, I'd be completely destroy the pattern. Yeah, a different type of problem. So let's do this one. All right. Now, forget the first rule. Okay. Forget the first rule. And second and third rule. Okay. This is one pair of rows. Okay. This kind of, you see that, right? Then the third one, fourth one have the same pattern as the second and the third row. Okay, so this shows a period. So how do you solve this problem? Okay, Crystal says D. Okay. I think we should delete, forget this first 5 students. Okay, so 2001, you have to subtract the 5 first. Then you start to the 6th student and go down. Each time, 8 students, 1 block, okay? 1 pair of the rows, 8 students, okay? So let's do this first, okay? 2001 minus 5, okay? You got 6, 9. It's gonna be 9,996, okay? If it's 85, then you get, right? And then you have to do, because then each block, right, there will be 8 students there. 8 students, right? Now let's see how many blocks you're going to get. So 1996 divided by 8. Right. So 7, 6, it's 9. Okay. So so this number is going to be 16 pairs of rows. Okay, right? 16 times 8 plus 4. Okay, plus 4. Yeah. So that means you're going to have how many pairs total? 16. No, sorry. When I'm sorry, I'm right down. 249. Yeah, 249 times 8. 249 times 8. Total, you have a 249 pairs of rows, and plus one partial row, one partial pair, right? Four numbers. So that means you are going to go. The last one will be just from here to here. Stop, right? So that's 2001, 2,990, 1999, 1998. Okay, right? So the answer will be, what do you got? A. Good job. Okay, so the answer is A. Right? So the idea that it's not, first of all, it's not a complete periodical, the pattern, right? But if you remove the first row, then you see a pair of rows shows up periodically. Okay? Then you just need to count how many pairs of rows, right? Because you deleted the first row, so you have to subtract the 5 students from 2001. Then you can easily count them like you can do the problem as before. Great. All right. So let's do an easy problem again. Then we continue. Okay. So in the following sequence of 540 letters, how many bees there? You still remember this problem? Okay. Well, $180, Nina says. Okay. So first of all, you identify the block, right? And then there are 6 letters in the block. So first of all, 540 divided by 6. Okay. Okay. So it's actually 90. Okay. So so 540 is going to be 90 times 6. There's got it. Okay. So there's no partial blocks, only complete blocks. So at the end. Okay. So you have partial blocks. Each block contains 2 bees. So the answer is 2 times 90. It's 180. All right. So now where's my problem number 10? Okay. Yeah, I'm going to delete that block. Wait. So here's a picture. Okay, you have this many squares there. We're using 46 pieces of a stick or the bars to make those squares. Okay, and how many squares you can make? Okay, actually you can get a complete square. So maybe you get partial square. Partial square, we don't count them. Okay, if possible, it's like that last one. You have, oh, one left, I cannot make a square. Or maybe only two left, then I cannot make a square. Okay, right? Just make a square, you know, one by one. Okay, now how do you solve this problem? I think we should do the following. This is the block, one block. It shows up periodically. Okay, this is how they count. Okay, then you see each block you use for each block, for each whatever I actually call block. Okay, use the 3 bars, right? Right. So then you know, 40 right, 46 divided by 3, then you get right. Okay. So 46 divided by 3, you get 15, the quotient, right? And 1 is the remainder. Okay. So that means you're going to get 15 of this kind of symbol, and you have 1 more left, then you close up. So you get a square at the end, right? So that's why total is going to be total is going to be 15, right? Clear, right? So you have to find out the symbols, show the figures which shows up periodically, right? And then how many such figures there in the sequence, and you get 15 of them plus a partial figure, which only 1 left, right? And it's just 1, and that 1 you can use that to close it to make a square. It's the last square. The total 15 figures. Each figure is not a square here. Yeah. Okay. If you yeah, so that is the best way to count the problems. Yeah, that is the best way to count the squares. Yes. Okay. So most of the problems here we just do the simple division and find the remainder, right? And remainder usually gives you the number of the objects in the 1 block, and then you can solve the problem. Okay. Good job. Okay. So now I'm going to talk about the homework problems. Yeah, let me move this problem to the top. Okay, some of you already maybe figured out. I want to discuss here. Okay. All right. So those are the 2 problems. They're a little bit difficult than other problems. Okay. So let me first read the problem first. Daniel's family consists of a Daniel, and his parents. So that means 3 people here, assuming, right? Daniel's father is 2 years older than his mother. This year, the sum of all family members' age is 60, but 12 years ago, the sum was 26. How old is Daniel right now? Okay. Well, if you want to count, let's look at the sum of the ages, right? So sum of ages this year 60. Okay. So let's do simple observation. 60. 12 years ago. If you go back 12 years, assuming everybody was there, right? Was there, right? So that means you have to minus 12, for, the sum of their ages, okay? 12 years ago. Okay, I assume all of them was there, right? So everyone have to subtract 12 years, right? 12. So then Daniel's mom also 12 years younger. Daniel, if he was there, also 12 years younger. Okay, so then you will get that's the sum of their ages 12 years ago, right? Let's count that. Then what do you get? Right? 60 minus 36, right? 36. So that will be 24. Okay? But you were given that the sum of their age is 26. So what's wrong with that, right? There's something wrong here. So that means your assumption is wrong. We assume assume that, right? Everybody were there, right? So Daniel was there, and his parents, of course, were there. Otherwise, right now there's nobody in the family, right? But there's a possibility. Don't forget that Daniel was not born yet. Okay, if Daniel, so that conclude this number is less than the given number, 26. So a contradiction. So we assume that Daniel was born. Okay. Under that assumption, you get the sum of the ages, which is 24, which is less than the given number. So that means in mathematics, that means the assumption is wrong. So we conclude that Daniel was not born. Okay? 12 years ago. Then the problem is a little bit easier. Okay, 12 years ago, and 12 years ago, the sum is actually the sum of the parents' age. Okay, so 12 years ago, more specifically, the sum of parents' ages was 26. Okay, that's a key point. Okay, not all the family members because Danny was not there. Then you can solve the problem because the sum of the age is 26, and then you can use the equation. You can use let me use the equation first. Okay, their father's age was I don't know, right? We don't need the father's age is always 2 years older than the mom's age, right? And the sum is 26. Now, can you solve this problem? Right, the sum is f plus m. F means father's age, father 12 years ago. M means mother's age 12 years ago. Okay, So according to the statement, right? Father is 2 years older than mother. F equals m plus 2. The sum of them ages is going to be 26. Okay? Then how do you solve this problem? Well, you just replace f by m plus 2. Okay? So in the place of f, the second equation, replace by m plus 2. Then you have a 2m plus 2 equals 26. Then you subtract 2 from both sides. You get 2m equals 24. So that means m should be equal to 12 because 2 times some number is 24. M is going to be 24 divided by 2, which is 12. And his father, right, his father is only 14. Okay, but that's okay. You know that's too young, right? They are separate. They're not married yet. That's fine. Okay. Now how old they are? Right now, his mother's age, right, is going to be you have to add 12. Yeah. Right? 12 plus 12 is 24. Okay, that 24 is okay, right? Then father's age, right, is 14 plus 12. That's 26. So they got married and they have a baby. Okay. So how old is Daniel? Well, how do you figure out the age of Daniel? Well, we know that the sum of the ages is going to be 60, right? So Daniel's age, right, should be, right? Daniel's age should be, hold on. Yeah, Daniel's age. He was just born. Let me check. 12 years ago, 26. Okay. So Daniel's age, the sum, okay, the sum of the ages, right, is going to be 60, right? But mother's age added together is 50. Okay, so that's why Daniel's age is going to be 60 minus father's age minus mother's age, which is 10. If you want to use a picture to solve it, then that would be, if you use a picture to solve it, and can you try this? Not using the equations. Some students maybe feel easier to use the pictures, right? But I wish you can, able to set up equations like that and solve. At least I see that some students have still trouble to write down the equations. You see, you have to name the variable. Say F means father's age 12 years ago, and M means mother's age 12 years ago, and then you read each sentence. Can you write down the relationship between those two letters? Okay, and Daniel's father 2 years older than his mother, then just write down F equals M plus 2. Then the sum was 26, then F plus M equals 26. Once you write down these two equations, it's half done, okay? And it's not easy to solve it. It just to show it to you, right? You replace F by M plus 2. Now this method is called the substitution method. Okay, there are two different methods to solve equations like that. One is called the elimination method. as one called substitution method. You substitute f with n plus 2. You get that from the first equation. Okay. Let's try to use the pictures. Here's mother's age. That's 12 years ago. Okay. That's the father's age. Okay, plus 2. Okay. So the sum is going to be 20. The sum is going to be 26, right? So sum is going to be 26. Add them together, 26. But that's just, look at this one block, right? And from here, you can quickly solve that. So this is a two-piece identical, right? The sum is 26. So just 2, immediately you can 2m plus 2 should be equal to 26. Almost still the same equation. So then 2m is going to be 24. M is going to be 12. Okay, so it's still almost the same. But if you look at the picture, when you add them together, right? Add them together, 26. How do you add them together? 2 identical yellow pieces plus 2. Okay. Yeah. 2 identical yellow pieces plus 2. And then, then this add them together should be 26. So otherwise, 26 minus 2 should be a double, the mother's age. Okay. The rest of them would be same. So let's look at this, the second problem. And this is a pretty similar. Okay, let me repeat again. Okay. Maxwell's family consists of Max, his twin sister, and his parents. Now, 4 members here. His father is 4 years older than his mom. And this year, the sum of the family members' age is 88. But 10 years ago, the sum is 58. Find Max's age. So we assume, first of all, you assume that Max was born, okay, 10 years ago. Okay, so then, so all of them are in the family. Okay, in that case, in this case, what is the sum of the age? Don't forget, don't look at 58. Okay, so the sum of his family members' age can be calculated in the following way. First of all, 88. 10 years ago, his father is 10 years younger. His mother is 10 years younger. Max is 10 years younger. His sister, 10 years younger. Okay, so you subtract the 40, let's get 48. Oops, 48 is less than 58. Right, 48 is less than 58. So that means you get contradiction. Now, if you get contradiction, that means your assumptions are wrong. Okay, you cannot assume Max was born 10 years ago. So there were number. Okay, so your conclusion is Max and his sister were not born 10 years ago. Okay. Then the big problem becomes simple. So let's take a look at 10 years ago. What happens 10 years ago? Okay, and I'm going to use a picture. His mother's age is his mother. His father's age plus 4. Okay, so this part is mother's age. Okay, the sum is going to be 58. Okay, now if you use a picture, maybe maybe it's easy. It doesn't matter how you solve it. You can add the 4 to this side, so makes 2 identical, right? Then you add the 4 here, right? then there's two identical lengths. The sum is going to be 42. Then 42 divided by 2, 31 will be his father's age. Got it? Yeah, because the sum of two identical pieces. I added 4 already, and I started a different way to solve the problem. I added 4 already to the top line. Then the sum will be increased by 4, so get to 62. Then if you divide by 2, you get father's age. Okay. Now another way to do is you subtract. Yeah, let me show you the picture. So here's a 4, right? Here's father. This is a father, and the sum is a 58. So if you subtract 4, it's 54. So mother's age will be, forget that part, right? It's subtract 4. So add them together, you double mother's age. So 54 divided by 2 is going to be 27. Okay, 27 will be mother's age. So depends how do you think about this problem. Yeah, depends how do you think about this problem, that you can find the father's age first, or you can find the mother's age first. Then, okay, once you find them ages, you can solve the problem. Okay, you can also use the equations. Yeah, mother. Then in this case, father is going to be 31st. Here, mother should be 4 years younger. It's 27. Depending on which one you find first. I can also use the equations, because father is always 4 years older than mother. So that's the first equation, no matter which year, because the difference is always 4 years, right? Then 10 years ago, the sum is going to be 58. So you got two equations. Okay? And the best way to do is to use a substitution to solve the problem. And this f should be replaced by m plus 4. So it will be n plus 4 plus m is going to be 58. Okay, then 2m plus 4 equals 58. How do you solve this equation? Right? You subtract the 4 from both sides. You get 2m. And 58 minus 4 is a 54. Then you divide by 2. You get 17. So you get mother's age. Then you get father's age, because mother's age is 17, and plus 4, that's going to be 31. That was 10 years ago. Now, okay, no matter which way you do, you get mother's age, father's age 10 years ago. And now what happens? Now, mother's age, okay, 10 years later, right? 17 plus 10, that was 27, right? Father's age will be 30. Wait a minute. Did I type it wrong? 27. Okay. Okay, 37. Okay. 31 plus 10, 41. Okay. So now we know that the sum of the family members' age, right? The sum is going to be 88, right? 88 including Max and his sister's age. Yeah, that including this time, including Max and his sister. Okay, all right. So how do you solve the problem? And here, add them together, 78. So the difference, 88, 78, right? The difference is 10, right? 10. So the contributed by Max and his sister's age, but Max and his sister, they are the twin, so they have the same age, right? So Max's age should be equal to 88 minus 78 divided by 2, okay? Because that is an increasing part, okay? It's going to be 5, okay? They're both are 5 years old right now. Okay, they're both 5 years old. So we're done with those 2 problems. Yeah, don't be confused when you cannot solve it. You know, you actually your assumption maybe is wrong when you solve the problem. There's an implicit assumption that, oh, you assume 10 years ago they were all born. Actually, it's not. That's why you get into some contradiction. Okay, if you get some contradiction, then assumption is wrong. You don't always assume they were there for 100 years ago. 100 years ago, nobody was there, right? So then you have to look at the problem again. So okay. Okay. I